This is a video for AQA Further Pure Mathematics. Matrices section 3.1, calculating inverses of matrices using a calculator. In previous videos, the idea of an inverse has already been met. So remember that for a matrix M, then its inverse is such that M inverse or M inverse M multiply together to give us I, the identity matrix. And we've seen also that for 2 by 2 matrices this is quite a straightforward process. So that, for example, if A is -2, 3, -1, 4, then we can see that the determinant of A is -8 minus -3, which is -5, and therefore the inverse becomes 1 over -5 or -1/5, and we swap the leading diagonal and change the sign on the other diagonal. For this matrix, if we try and work out the determinant of B, then we find that that is equal to -6 minus -6, which is equal to 0. And therefore we can't find the inverse, and we refer to this as being singular. So a matrix that has determinant equal to 0 is a singular matrix. For 3 by 3 matrices, actual notation and the idea of singularity are still the same. So we refer to the determinant of M either by saying det M or using the symbol with the two straight lines, or we can call it delta by using the Greek letter, capital delta. And as I've already said, if the determinant is equal to 0, then M is singular, so we won't be able to find the inverse of the 3 by 3 matrix. So again, for a 3 by 3 matrix, we have the same idea that M multiplied by its inverse gives us the identity matrix. The difference, of course, being that for 3 by 3 matrices, the identity has got 3 rows and 3 columns. But again, you can see that we've just got ones on the leading diagonal of the matrix. I've already said that the inverse only exists if the determinant is non-zero. Now, actually calculating the determinant of a 3 by 3 matrix is a little bit more complex than we have for 2 by 2. However, you can do that on a calculator, and you ought to make sure that you can. So you need to know how to use your own calculator to input matrices, find the determinants of those matrices, and to find their inverses. So that's vitally important because some questions may require you to use a calculator. We will look in subsequent videos at how to calculate the inverse of a 3 by 3 matrix by hand. However, for the time being, we're either using a calculator, or indeed there are some questions that we can answer without actually being able to or needing to find the inverse matrix itself. What I'd like you to do at this point is to either pause the video and just check that you do know how to use your calculator to enter this matrix and then to find the determinant and the inverse of the matrix. If you don't know how to do that, then what you need to do is probably stop the video at this point and find out how to do this on a calculator before you proceed. So as I say, it's vitally important that you do know how to use your calculator to find the determinants and inverses of matrices. So using a calculator, you should have found that the determinant is equal to 1 and the inverse is given by this matrix here. We can check that the inverse is correct, of course, by just doing the multiplication of M multiplied by its inverse, and if you do that, you will see that we get 1s on the leading diagonal and 0s everywhere else. So straightforward enough to check that a inverse is correct. This time a slightly different determinant to find, so I'd like you to enter this matrix into your calculator and calculate the determinant. And what you should find is that for this one you get that the determinant is equal to 0. So therefore, if you try to find the inverse of the matrix that you've entered into your calculator, you should get an error on your calculator because it's telling you that the inverse doesn't exist. This is a singular matrix, or this is the determinant of a singular matrix. Here's a question that we can answer without necessarily being able to find A inverse directly, so that we can just use our knowledge of matrices. So we know that if we have A and A inverse, that multiplying them together is the identity matrix, and therefore we can look at the first row of A and the first column of the inverse, which will include P, so that if you multiply those out you get 10 minus 1 plus 2p, and of course the answer to that being first row first column of the identity must be equal to 1, and that gives a value of p equal to -4. If you look at the first row multiplied by the final column, and this time we get 14 minus q minus 12 is equal to 0, and therefore you get that q is equal to 2. So that looks at solving little equations by knowing about inverses and how they multiply together with the actual matrix itself to give us the identity. What we'll do in subsequent videos is look at how we would calculate the inverse directly from the matrix A itself. So that's the end of this introductory video. In the next video we'll start this process of finding inverses by introducing the idea of minors and cofactors of a 3 by 3 matrix.